Strings and numbers are two different data types. On the screen you see the string containing the characters 1, 3, and 2. And on the right side of the equals comparison operator you see the integer number 132. The equals comparison operator returns true if the two items are the same, or it returns false if the two items are different. The values true or false are displayed on the screen with the puts command. Now I'll run the program, and as you can see, the command outputs false. Please remember, the string consisting of three characters 1, 3, and 2 is not a number. It's a sequence of three characters, while 132 is a number with 3 digits with place values. True and false are of the Boolean data type. A Boolean data type has only 2 values, which are true or false. Now let's look at basic arithmetic operations available in Ruby. You can see that Ruby uses the plus sign for addition, and the minus sign for subtraction. It uses the star or asterisk symbol for multiplication. It uses the / for division, and it uses the % sign for the modulus operation, which we'll discuss further in lesson 6. And finally, it uses star or asterisk for exponential or power calculations. An issue that oftentimes comes up in programming is using the concatenation operator to join a string to a number. Here's an example which has an error. So we'll go ahead and run this to see what happens. Part of the purpose of running this is to show you what an error message in Ruby looks like. We have the path and the file name, bad concatenation.rb. The second item in the error situation is the line number where Ruby thought it made a mistake, so you could look back at your program. And the third thing is the error that Ruby thought you made. It says in the concatenation operator, no implicit conversion of fixed num into a string. That's a data type error. There are a couple of ways to fix this. Let's go over them fairly quickly. We'll go ahead and comment this out since it has an error, and we'll come down here and do puts. The answer is concatenated with 60 times 4, and we have to do an explicit conversion using the 2_s. That stands for toString. And so it will take 60 times 4 to get 240, and then it will convert it to a string 240, and then we'll take that string 240 and join it onto the string the answer is as one long string and put that on the screen. The other technique is to use what we call embedded, and you can embed calculations or variables. And so we'll use the pound sign. Inside the quotes, it's the embedding character. Outside the quotation marks, it's a comment. So we'll embed 60 times 4. Again, Ruby will evaluate the calculation as 240, and since it's embedded inside of a string, it'll convert it into a string and display the result. So when I run this, I should get the answer is 240. Let me go back here and put some quotes in there, and let's see what we get. The answer is 240. The answer is 240. Now we need to talk a little bit about a program that allows us to input some values. And I thought of the old days old program, which calculates and displays the number of days old you are given that you enter the number of years old. So we would also like it to show the person's first name as part of the output. So when we run this program, we want to say, first name, you are X number of days old, such as Bill, you are 3,852 days old. This is a little longer program. I put a comment block at the top of the program with the name of the program and its overall purpose. We'll start out with a little comment. We'll say get first name, and the way we'll do that is we'll print a prompting message. When this runs the program, it'll say enter your first name. And then we want to get that and store it in a variable. The variable I'll use is first underscore name, and that's equal to, and the command in Ruby that you tell it to wait for keyboard input and gather it together and store it in a variable is called the gets. Now that stands for get string. What happens though, the computer stops and waits for you to type in something, and you press the enter key to tell it you're done, and it will actually store the enter key as a new line character as part of the string. So we can use the chomp method to remove the carriage return at the end of the line. Next item we'll get is the age in years. So we'll print enter your age in years. We'll use the variable years old to receive the input of the gets command, but the problem is gets a string of characters. So if you enter 200 or 240, it stores it as 240. We don't want that. We want the number 240. So we'll use the data type conversion here to underscore I to convert the string into an integer. We've looked at input of a string in line 8 and input of an integer number in line 12. Now let's go ahead and calculate days old equals, and you probably have thought this through before, 365 days in a year times the number of years old. Now we'll print out the results. I'll do these as embedded values. So we want to print the person's first name, which is embedded in the variable first name. I want to print a comma after that and print you are, and then I want to embed the value days old that we calculated in the line directly above, and then I want to put in the output the word days old. It should run okay, so let's give it a try and see what happens. Enter your first name. Well, I'll use my first name. You can use yours. Gary. Enter your age in years as an integer. Well, I'm 65 years old. Every one of them a good year. And press the enter key. And it says, Gary, you are 23,725 days old. Looks like I have an extra comma in my output here. Don't know why I slugged that in there, but we'll take that out. And we've got the program. In Lesson 6, we'll look at more arithmetic. We'll look at the modulus operator and the division operators. And we'll do that arithmetic on both integers and floating point numbers. Thank you for listening, and goodbye for now.